Next one, we can obtain the same V is equal to square root of 2gr even from conservation of energy also. Even from conservation of energy principle also we can obtain the same. So for example, here what we are taking, this is the earth is here, and again the body is projected from this point, and it has a gravitational potential energy on the surface, and here the total energy, and when it is taken, here the total energy both have to be same according to conservation principle. So that's why according to conservation principle, TE at TE on surface is equal to TE at infinity. TE on surface is equal to TE at infinity. TE on surface means what you have to take, that you have to take the potential energy, and again the next kinetic energy, and TE at infinity means that is also PE at infinity and PE KE at infinity that you have to take, and for that one. So first of all, PE and on the surface is minus capital G capital M small m by R. This is R to be taken. So minus capital G capital M small m by R. So that is gravitational potential energy on surface of earth, and kinetic energy means 1 by 2 mve square is there. 1 by 2 mve square, and potential energy at infinity is equal to 0 because the maximum value of that gravitational potential is the 0. So potential energy at infinity is the 0. Now at infinity that becomes a 0. Next, kinetic energy means, just now I told, it is on reaching that infinity, its velocity becomes a 0. So that's why it is the minimum velocity with which we are projecting. That's why here also it will be 0. And therefore 1 by 2 mve square is equal to gmm by 2r, sorry, gmm by r, and thereafter same thing. That is again we are getting that V is equal to square root of 2gr. So this can be taken as a second method while you are in getting that escape velocity. This is according to that conservation principle. Next, we can take some cases in this escape velocity also. Now here in this case, suppose if the body is projected, if a body is projected not from the surface of earth, so it is at a height which is at a distance smaller, definitely smaller greater than capital R here. So in that case, what would be that escape velocity? What would be that escape velocity? In that case, you have to take that formula, VE dash is equal to square root of 2gm by smaller only, because actually VE is equal to square root of 2gm by r, and here VE dash means, suppose if at all it is projected from here, it will be VE, and if it is projected from here, it will be VE dash, and VE dash is equal to square root of 2gm by r. So that's why as this value is greater, this escape velocity will be less. So therefore VE dash less than that of the VE. So but in this case, you don't apply that formula, that is VE dash is equal to square root of 2gr, you don't apply. So this is not correct. Even though VE from the surface of earth is square root of 2gr, but from some height which is that is the distance is smaller, which is greater than that of the capital R. In that case, you don't apply this formula. Why? Because here you have taken that small g same in both cases, but it cannot be same, because when the body is projected from some height which is above the surface of earth, and small g definitely will change, because already we have proved that whenever that body is going to that altitude, that is small g decreases. So that's why you don't apply this formula. So you have to apply, if you want to find out that new escape velocity when it is projected at some height like this, you have to apply this formula only, VE dash is equal to square root of 2gm by r. Next one is, we are coming to that next case. Suppose if at all a body is projected with a velocity that is nve, n times of the escape velocity, like this. So nve, in that case, on reaching that infinity, what would be its velocity? Because suppose if it is projected with a velocity ve only, then on reaching that infinity, its velocity becomes 0, just it is reaching the infinity. Now in this case, we have projected the body with nve, then what is that velocity on reaching this infinity? So this is the infinity and it will be the v. We consider that velocity will be the v. And here also we apply that conservation of energy. So according to that conservation of energy, TE on surface, so you have to remember one point, that is almost majority of the problems in the gravitation depends on the conservation of principle only. So that's why here TE on the surface is equal to TE at infinity, applying that conservation of energy. So TE on the surface means it is the PE is there, and again the kinetic energy is also there, and it is the TE at infinity means PE, and again the kinetic energy is here, but this is for the infinity and this is for that surface only. And on that surface already you know it is nothing but minus G, so minus capital G and capital M small m by R. On the surface of earth it is gravitational potential energy is this much. And again the kinetic energy can be taken as a 1 by 2 mVe square. VE means it is the nVe whole square, because here in this new case that is the projected with a velocity nVe. So nVe whole square is here, and PE plus KE means PE on reaching that infinity, then definitely it will be the 0, and kinetic energy means 1 by 2 mV square is coming. 1 by 2 mv square is there, and here minus gmm by r, that is nothing but 1 by 2 mve square. Just now from that principle of conservation of energy we have got that minus gmm by r plus 1 by 2 mve square when it is projected from the surface of earth is equal to 0. So that's why here 1 by 2 mve square is equal to gmm by r. So instead of this minus gmm by r, what we can write 1 by 2 mve square, and it is 1 by 2 m n square v square is here. N square v square is here, and as usual that is 1 by 2 mv square is also there. 1 by 2 mv square, and 1 by 2 m will be taken, that is cancelled on both sides. So v square is equal to, now here it is a v square is taken common, that becomes 1 plus n square is here. So 1 plus n square is here. So now here it is v is equal to square root of n square plus 1 of VE. So this answer. So once again I tell you, first of all TE on the surface, that is TE at the infinity, and TE on the surface means PE plus KE. So PE plus KE means potential energy on the surface of earth is minus gmm by r, and kinetic energy is 1 by 2 m nVe square is there, and PE at the infinity it is 0, and KE at infinity is 1 by 2 mv square is here. Now minus gmm by r is replaced by 1 by 2 mve square, because just now we have proved minus gmm by r plus 1 by 2 mve square is equal to 0, that is the total energy to infinity. So that's why 1 by 2 mve square is equal to, now we can prove it is the minus gmm by r. So that's why it is replaced by 1 by 2 mve square. Here you are going to find out that v square value, and here v square is equal to, now when you are taking that v square as a common, n square plus 1. So now it is v is equal to square root of n square plus 1, and again that v is there into v. So that is the velocity, of that body on reaching infinity. That is the velocity of that body on reaching infinity. V is equal to square root of n square plus 1 into VA. Now, so far we could complete in planetary motion Kepler's laws, and thereafter orbital velocity, and geostationary satellite, and gravitational potential, and thereafter this escape velocity, and again that is the second method applying that conservation principle, that is escape velocity, and thereafter finally we are coming to that energies of a satellite. So energies of a satellite. So in these energies what we have to take, the first one is potential energy on the surface of earth. So potential energy on surface of earth is, now it can be taken on surface of earth potential energy. It is PE is equal to minus capital G capital M small m by r. Potential energy on surface of earth is minus capital G capital M small m by r. Next one is a potential energy at a height h on surface of earth is over, and at a height h. In this case at a height h, that potential energy is, so that h can be taken from the surface of earth. So that's why it is PEH is equal to minus gmm by r plus h is there, because all these distances in denominator like this, in the denominator they have to be measured from the center of earth only. So you cannot take directly this h, so that's why r plus h to be taken. All these distances are to be measured from the center of earth only. So minus gmm by r plus h. Now we are coming to this delta PE. What is the change of potential energy from the surface to this height? What is the change of this potential energy? So this can be taken PEH minus PE to be taken, because gravitational potential energy increases. Whenever you are moving altitude, whenever the body is taken to heights, that gravitational potential energy increases. So PEH minus PE, it is a minus G capital M small m by r plus h, and again the minus of a minus, that becomes a plus, and capital G capital M small m by r is taken. And thereafter capital G capital M small m of 1 by r minus 1 by r plus h is there. 1 by r minus 1 by r plus h is gmm is taken common, that becomes 1 by r minus 1 by r plus h is here, and this is the formula. So this is the delta PE, and this formula is applicable only when you are given that mass of the planet, and again this r, and again like this. Suppose the same and capital M and again the capital G, if you want to apply, then it is a formula. And suppose if the small g is there, and now in that case this formula can be transformed into delta PE is equal to gm, G capital M small m is here, and thereafter r of r plus h is here, r of r plus h is here, and now it is r plus h minus r, so that's why h will be there, r plus h minus r, so that's why h remains there. Next it is gm. Gm can be taken as already we know g is equal to gm by r square, so that's why gm can be replaced by gr square. So mg r square is here, and h by r of r plus h is there. And thereafter, after cancelling this one, now it is becoming mgh by r of r plus h. So now it is mg r square is here. So once again, that is gm is equal to gr square is there, and thereafter mg h by 1 plus h by r. Now it is r is cancelled here. Now mg hr, after that mg hr by r plus h is here, like this. So now this is the first delta PE. Delta PE is equal to PEH minus PE is there, and minus gmm by r plus h, and plus gmm by r, and delta PE is equal to gmm of 1 by r minus 1 by r plus h. And here we are taking that LCM, that is r of r plus h is there, then only h remains. Now in this case it becomes g is equal to gm by r square, gm can be replaced by gr square. So that's why here in place of the gm what we can apply, it is gr square is there, and one r is cancelled here. So that's why it is mg r remains, and h is already there, and r plus h is there. Next that can be taken here mgh of 1 plus h by r.